Welcome to this year's presentation of A Baker's Dozen of Solid Edge Tips and Tricks, Part 1. My name is John Pearson and I will be your presenter. Now normally I would be doing this presentation live at one of our many fall shows in cities like Toronto, Winnipeg, Red Deer, Chicago, and Montreal. However, this year the pandemic has prevented us from traveling. Therefore, I am doing my popular Baker's Dozen of Solid Edge Tips and Tricks presentation through our blog. It will be posted in 2 parts. I hope you find these useful, and hopefully next fall we can present them live again. The first tip or trick we'll look at is the use of the normal to curve reference plane. This reference plane can be used in ordered or synchronous paradigm, and it generates a plane that is normal to a curve or a part edge. And it literally follows that curve or edge and always remains normal to it. You can position it using a distance or a scalar positioning. So for example, if I go in and type 0.5, it'll put it dead center right at the midpoint of that edge. This is ideal to use for placing sketches for the swept protrusion command or the contour flange command. Allow me to demonstrate this in Solid Edge. I'm going to start in a part environment, and you'll notice that I'm in an ordered paradigm, and I have this existing B-spline sketch here, and I want to put a circle on here and sweep it. So what I'm going to do, I'm going to go in and create my circle sketch, and I'm going to use the plane normal to curve option here. I'll select the curve, and notice I can place it anywhere along this curve, and notice how the plane always stays normal to the curve. So I can now go in and type 0 in here, or I can just hold the cursor towards the far end and click. And now I'm going to go and place my circle, and I'm going to look for that pierce point. So that's where that end point is piercing the plane. Let's make that 10, and we'll close and finish our sketch. So now I can quickly go in and just do a quick sweep. And that plane normal to curve made it very easy to place that and sweep it. Another example of using the plane normal to curve, let's go into a sheet metal environment and in Synchronous here. If you're not familiar with the Synchronous environment, one of the things you do need to do is have a sketch before you can run the commands. You'll notice that, for example, the contour flange is grayed out. So we want to put a sketch down here for our contour flange, and a quick way to do that is use the plane normal to curve again, select that endpoint, and place that right at that endpoint. It's a little easier sometimes to do that than to try to pick on the 0 thickness face there. So now I can go in, I'll lock to this plane, I'll go in and draw my sketch, make sure I'm getting the endpoint. Let's bring this out here, let's say 12 millimeters. And we want to have this, let's go to our sketch view, and I want to have this come straight out. Go back to our home view, escape out of the sketch command. Notice the contour flange has become active. I can select it, I'll select the sketch, and then I'll select the arrow and start placing my wraparound contour flange. Let's go in and just make a quick tweak to the options. Let's make that closed. And one more time, close the treatment as well. And there is our finished contour flange, again using the normal to curve reference plane. Let's go back to our PowerPoint. The next tip or trick I want to look at is the clean sketch command. Now this is a really nice command that was added back in ST5. If you're dealing with imported sketch geometry, this will help you clean it up. So the clean sketch command removes duplicate or degenerate geometries and cleans B-spline curves. As the tip says here, cleans imported curve data and removes duplicate and small geometric entities from sketches. So it's really good if you're dealing with foreign sketch data, layout data, this type of stuff. And in terms of B-splines, what it does is it cleans the input curve to create a valid curve entity. It'll remove self-intersections and removes discontinuity typically caused by duplicate control points. The other thing I really like about this command is it gives you the option to delete the removed elements, or you can move them to a different layer. If you're worried about losing something, you can run this command and put it on a different layer to see the results if necessary. Let's have a look at this in Solid Edge. In this example, I have some foreign data imported into Solid Edge draft environment. And if we look at this data, you'll notice it's elaborate B-splines with numerous control points and so forth. Quite messy geometry in terms of potential problems when you have it this tightly packed with control points. What I'm going to do is I'm going to use the clean sketch command. And the options here is to clean the B-spline. And I'm going to delete any duplicate elements and so forth, any unwanted geometry. I'm going to say OK. I'll fence select it and hit finish. And you can see now that it has broken this up into multiple B-splines. Maintain the overall shape, but it's a lot less control points and a lot easier to work with, and a lot less potential for any errors. So it's that simple using the clean sketch command. Another good example is here's a layout that we brought in from AutoCAD, and you'll notice if I go down here and right click on it, notice how many lines are on top of. There's 5 lines in that one section, and unfortunately this happens a lot in 2D geometry, especially from AutoCAD. We have tendency to have overlapping lines. So let's run our clean sketch command again, and this time, however, rather than delete it, just to show you what happens, I'm going to move this to a different layer, the deleted items or the unwanted items, and I'm going to actually create a layer on the fly here. We'll call it clean. I'm going to window select this or fence select it and hit finish. And now what I'm going to do is I'm going to go and make the clean layer active and show only. So you can see all the lines that were unnecessary in there. In fact, I'm going to go now and delete these and show all again, and you can see that we have the exact same layout, but we don't have all the underlying duplicate lines in there. So again, that's the clean sketch command. If you're dealing with any foreign 2D geometry, it can really help you. It's an amazing little command. For tips and tricks number 3, I'm going to look at the Lofted Vertex mapping. Now with our Lofted commands, the automatic vertex mapping algorithms help achieve better creation success without user intervention. Unfortunately, there's too many real-world combinations to make the automatic method work 100% of the time. So we have manual vertex mapping, which gives the user the ability to fully control the parameterization of the lofted flange or feature. Now in sheet metal, this is relatively new. It was added in the last release. So we have it in 2020 and 2021. So let's have a look at this first. For this example, we're in sheet metal, and I just want to remind you that you can only do this in 2020 or 2021. We'll go in And because it's a lofted flange, you can only do this in the ordered paradigm. So I'm going to go in and select this sketch, accept it, this sketch, accept it. And in my options, I want to make sure that I have bends turned on. And I can pick my material side outside. Now, you'll notice that the automatic mapping has made a bit of a mess of this. So what we can do is go back and do manual vertex mapping. And you'll notice we already have the first set. So we can go in and say, let's add another set here. Let's add another set here. And we'll add one set back here. Now you can do more. For example, you could go from there to there if you wish, but we'll just do these for now. We'll say OK. And you can see a much better result. And we can even go in and turn this into a flat pattern if we wish. So manual vertex mapping allowed me to create the shape that the automatic could not do. Let's go back to our PowerPoint now. Now in the part environment with Lofted commands, we've had vertex mapping for many years, as far back as I can remember. And again, the automatic vertex mapping does most of the work, but on the rare occasions you're going to run into sketches that have different number of vertices than each other, and it could cause some issues. So let's have a quick look at an example in the part environment. In this example, I've created two sketches. You notice we have different number of vertices here. I'm just going to go in and create a lofted protrusion, and we'll go from this corner to this corner. If I hit preview, the system tries to map it as best as it can, and you notice that it's not exactly what we would call a symmetric shape by any means. So I can go back and do some manual vertex mapping. I click on the extend step, select the vertex mapping icon, and again we have our first set which defines our two start points. So I'm going to say add. I'm going to from there to there. I'm going to say add from there to there, and then add from there to there. I'll close that and hit finish. And you can see a much better result, more symmetric, better behaved model. So again, that's the manual vertex mapping in the part environment. For tip number 4, we'll look at the part to sheet metal command. This gives you the ability to encase and transform an ordered model into a sheet metal part that can be flattened. So for example, if I have this box here, I can actually build a sheet metal box around it. So this command is located under the Tools tab. It is an ordered only command. It only works in the ordered paradigm. So once you go into this command, you're prompted to select linear edges or cylindrical faces. These will be the edges that you're going to turn into bends. A bend icon is displayed, and you click on it and you can override the default bend properties from the gauge tab in the material table. You can also change the material thickness at this point. In order to create a valid sheet metal document from a part model, some edges or faces need to be ripped. Now you have the option of selecting either an edge or a sketch as a ripped edge, or the system will attempt to put in automatic rips where appropriate. So in this example, I've put a sketch across here, and I actually want to rip it down here, so I can hit the R key and select this sketch, and it'll generate a rip through here for me. Let's have a look at this in Solid Edge. So in this example, we have two protrusions that I've created in the part environment, and I've switched to sheet metal. Now we can go up to Tools, select Part to Sheet Metal, I'm just going to accept this for now. I'll say OK. And then I go around and I start picking the edges that I want to bend. And you'll notice I'm getting red dots and icons appear. So as I hover over here, I can see the bend icon. So if I wanted to change something about this bend, I could click on it and override the default settings that I had accepted. You'll also notice that if I click on a corner here, I can change the close corner or the corner treatment from closed to open or none to closed. So I can change the various corner treatments wherever there's a red dot. You'll also notice the system generated a rip automatically for me, so I didn't have to do it in this case. Once I've got everything set up, I point my arrow in the direction for the material side and accept it. And now let's turn this into a flat pattern. You can see what I have actually done is created this encasement. So we can go turn this into a flat pattern and you can see the result. So a very nice command if you want to create boxes or encasements over solid bodies. Next, I want to show you some tricks on restoring consumed faces in Synchronous technology. For those of you working in Synchronous technology, you know that the only thing that matters in Synchronous technology is the state of the geometry right now. It doesn't matter how it got there, all that matters is the current state. Therefore, if you consume a face during the modeling or editing process, Synchronous forgets that the face ever existed. On occasion, this may cause some issues, but these can be dealt with. A couple of tricks you can use is either to manually restore the face or use integrated modeling. Let's have a look at this in Solid Edge. In order to demonstrate this, I've put together a very simple example. And you'll notice here I have some locked dimensions. And I'm going to go in and place a round of 25 millimeters. Now you'll notice that 25 millimeters is the height of that wall. So if I place that in, that face from that wall disappears. It's totally consumed. So now the system doesn't even remember that that face was ever there. It totally forgets it. If I go in later and try to change this value back to 10, you notice I get an error. It doesn't know how to recompute this, especially since these are locked. If I unlock this and then change that to 10, notice it pulls this up as opposed to putting back that face, because it doesn't know that that face was there. It forgets that it was ever there. So how do we fix this? Well, there's two things. If you've already in Synchronous and this has happened, all you have to do is redefine the face. And a quick way to do that in this case is just to go in, we'll lock onto that face, and we'll come straight down, and then we'll do the same over here, and we'll go straight across, and then we'll go and do a protrusion and say through all. And then we can add our round back of the original value of 10. And you can see we've re-established that face simply by recreating it. And the system only cares about the current state, remember. Now, another way of doing this, let's undo this, go back to our original model. If we recognize that it's a treatment feature that's going to consume this face, what we can do is treatment features are generally done at the end of your modeling process. So we can go up and use integrated modeling. And to do that, we go up to Tools, and we switch to the ordered paradigm. So now we're in the ordered paradigm. Our base features in the Synchronous, and in the ordered paradigm, we're going to put in a round of 25. Now, because this was in the ordered paradigm, if we choose to edit this and put it to 10, the system remembers that that face was there, because remember, ordered remembers not only the current state, but it also remembers how it got there. It remembers the history. Where with synchronous, it doesn't remember the history. So by using the integrated approach, you get the best of both worlds in this case. So there's two ways to deal with a consumed face in synchronous technology. Our next tip is to introduce you to assembly restructure commands. Now, for those that don't know what assembly restructure commands are, we provide two commands, and this provides the ability to modify assembly structures with the following commands. We have the transfer command, and this transfers the selected part or parts to a new or existing assembly. And we have the disperse command, and this disperses a subassembly by reassigning the parts to the next highest subassembly and removing their reference to the existing subassembly. So these are great ways to build or disperse subassemblies within the assembly itself. So let's have a look at this in Solid Edge. So I'm going to use this simple assembly to illustrate some of our restructuring commands inside the assembly environment. And let's start by going into our configuration here and turn on the configuration of the ball stem here. And you'll notice that this is all made up of individual components. There's no subassemblies. Perhaps I want to use this several times in different valves. So what I can do is I want to turn this into a subassembly. Well, I can do that directly inside of the assembly. And what I'm going to do is I'm going to select these components. And when I select a part or parts, the transfer command in the modify group on the home tab becomes active. I can select the transfer command, and now I have the option of putting these into existing subassemblies, or I can click on the top level assembly and it gives me the option to create a new subassembly. So I'm going to select new subassembly. I'll give it a name. I'm just going to call it stem, for example. And I can control the positioning. I'm going to use maintain current offsets from the assembly origin. And I've selected my assembly metric assembly template here. And then I'm simply going to say OK to that. And OK here. And you'll notice what's happened is all those parts have been condensed into a single subassembly now. So let's turn on the rest of our assembly here. So I've taken a bunch of components inside of one assembly and created a subassembly on the fly internal to this assembly. Now you'll notice here I have a gasket part, and I've created that and I've brought it in and I've placed it inside here, and you'll notice there's a gap over here to do it again. So I could do that, and I have two gasket parts, or I can notice that this end component here, let's say show only, this is a subassembly already. So I can turn the gasket on, and what I want to do is I want to add the gasket to this subassembly rather than place it multiple times. So to do that, I select the part, I go up to the transfer command, and now this was made with an inner part copy, so it's giving me a warning that this could break that relationship. I'm going to say yes, and then I'm going to pick the assembly that I want to add it to, and then I'm going to say OK. Again, it gives you a warning. It's saying that this target subassembly occurs more than once. This transfer will affect all occurrences of that subassembly. Therefore, the total part count might change. So I say yes. So it's giving you a lot of warnings, so it's hard to mess this up. And now we can go back and turn on our top level assembly, say show all. And you'll notice that this is now part of this assembly, and it's showing the gasket there. So you can see transfer command allows me to create an entirely new subassembly or add parts to existing subassemblies. Now let's say that we determined that for some reason we shouldn't have this as a subassembly because there's too many variations and I want to break it up. So I can go back into my stem assembly, I select it, and I can go up, and notice we have the disperse command. So I click on the disperse command, and it says transfer the parts in the selected assembly to the next higher level and delete the selected assembly occurrence. I say yes, and now that subassembly, the stem subassembly, is now gone, and all the parts have been broken up and put in the upper level assembly. So again, that's the transfer command and the disperse command. Very useful commands when working in the assembly. And this brings us to the end of part 1 of this presentation. Look for part 2 in my next blog article. If you want to learn more about Solid Edge, check out our new online training webpage at this site. And I'll just show you real quick. Here's the page, and you'll notice we've added lots of courses here, and there's more coming in the new year, more of the advanced stuff. So we have our Synchronous courses, for example, and we have our fundamentals and ordered basics, and we will be adding NX fundamentals and Team Center fundamentals coming soon. And in the new year, I'll be putting up advanced assembly and advanced modeling. So keep an eye on this. There is a cost to this training. If you click on the enroll, you can find out the price or talk to your account manager. If you have any questions, contact us at info@designfusion.com or contact your account manager. This completes this part of this presentation.